A network of 4 capacitors of capacity equal to C1 equal to C, C2 equal to 2C, C3 equal to 3C, and C4 equal to 4C are connected to a battery as shown in the figure. The ratio of the charges on C2 and C4 is A 4 by 7, B 3 by 22, C 7 by 4, and D 22 by 3. From the figure we can understand that all these capacitors are in series with as parallel to C4. So we can redraw all the three series connected capacitors as one capacitor with their equivalent capacitance in parallel with the C4. Now we have this series connected capacitance equivalent capacitance which we have to find right now. We know for a series combination of capacitors the formula is 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So let us substitute C, 2C and 3C and we get, so after doing all the rearranging and taking LCM part, we get Cs, that is capacitance in series, is equal to 6C by 11. So we got 6C by 11, so we can write 6C by 11 over here. Now we have to find the total capacitance in this circuit. To find the total capacitance, the series connected Cs is connected in parallel to C4. We know for parallel connection we have C net is equal to Cs plus C4. You can just add. So we have 4C, no, Cs is 6C by 11 plus 4C, which we can take LCM and write, we'll get it as 44 plus C, which is 50C by 11. We know the formula for charge is equal to Q is equal to CV. So let us find Q net, which is Q net is equal to C net into V. So C net is 50C by 11. So we have 50C by 11 into V. Now to find ratio of charges on C2 and C4, C2, C1 and C3 will have the same charge because they are connected in series, and that charge will be the same as the total charge. So we just had to find the charge passing through Cs capacitance in our modified figure to find charge on C2, and similarly we can find charge on C4 and take a ratio. To find charge on the first arm, that is Q1 or Qs, we have to write Q net into Cs by Cs plus C2, which we can write it as 50CV by 11 into Cs is 6C by 11 divided by Cs plus C2 is the C net we found, so it will be 50C by 11 itself. So we can cancel 50C by 11 and 50C by 11 over here, and we get 6CV by 11. Now let us find Q2, which is the charge in second arm or charge through C4. So Q4 will be equal to Q net, the total charge, minus the one in the first arm. So we have Qs, which will have 50CV by 11 minus 6CV by 11, which we can write as 4CV. 50 minus 6 is 44, so we have 44 by 11, 4. Now the only thing to do is Q2, Qs by Q4. We'll get the answer, which is the ratio. We know Qs is 6CV by 11, and we have Q4, which is in the denominator, 4CV. Now let us cancel CV and CV. We can also cancel 6 and 4 by dividing it by 2. We'll get 2, and here we'll get 3. So our overall answer would be 3 by 2 into 11, that is 22, which we can find is our option B.